this back in a shoveler.
Hey guys, and welcome back. So today we are going to be talking about ecological pyramids. Now I know we talked about food chains and we talked about food webs. So what's an ecological pyramid? It's almost exactly the same as a food chain and a food web, except it's just a different way of showing it. Just like how you have different models for how things work, just like some people will read a book and look at one picture to show how relationships work, well, another person will watch a movie to understand how things work. So it's just another way to explain natural causes and natural order of things. So what we're going to do is a little bit of an experiment and with our boxes. Alright, so let's start with our pyramid. Alright? So I got several boxes to represent each layer. Now of course I don't have like a really cool pyramid, but we're gonna make one, so it'll be fine. And you can make this at home too if you would like. All right, so we're gonna start with the bottom. Yes, I'm aware it's an Amazon box. All right. So what is this bottom box is gonna represent? Is it's gonna represent our autotrophs. Do you guys remember what an autotroph is? Right, it is anything that can create its own energy, meaning things like plants. So we're gonna take our handy dandy crayons and we're gonna make some plants. So there's already some plants on here, but I'm just gonna draw giant blades of grass. I know it's not perfect, but it is what it is. All right, so we have our plants. Plants, autotroph. All right. So we have our autotrophs, right? So that's going to be the bottom of our pyramid. After that, we're going to have a heterotroph. So just for easy sake, just like our other ones, I'm just going to make it a rabbit. All right, so we're going to draw a little bunny. Doop, doop, legs. Okay, its head is proportionately way too big. But you get the point. It's a rabbit, right? Little rabbit. And he's gonna go up here. We then will have what will eat the rabbit, right? Does anybody remember what ate the rabbit? That's right, so something like a snake. So we'll just draw an indescript snake. All right, so then we got our snake. Well, I guess I'll write snake. Snake. Alright, so we have our autotrophs on the bottom, we have the rabbit, and then we have the snake. And I know it's hard to see, I could not find my markers. So, then we have our last box. Now I'm not going to draw on this box because it's actually a jewelry box, but we're going to pretend this is our hawk, right, our apex predator. So we have our autotrophs on the bottom, then we have our first heterotroph, then we have our second heterotroph, and then we have our apex, making our whole linear thing. So what the ecological pyramid is showing, it is showing the energy flow through, all right? So energy is being given to the sun, to the autotroph, right? So the autotroph actually gets the most energy. Every single time it converts up the pyramid, it loses energy to heat, all right? So we're gonna do our first experiment. We're gonna start with some soda. Hope you guys like Dr. Pepper. So how this is going to work, we have our autotrophs. Our autotrophs have the most energy. So we're going to go ahead, see if I can do this one-handed, and pour 500 milliliters of soda, which will represent our energy. So the plants get 500 milliliters of energy. So there's one. Hope it'll fit. All right. All right, 500 milliliters. So all of that energy, because they converted it themselves, they didn't lose any energy to heat. So we're gonna pour it in our energy. So the plant's got 500 milliliters of energy. All right, now for our poor little rabbit, each time it goes up the pyramid, you lose 10% of energy to heat. So he lost 10% off of the energy. And how you figure that out, if it's 500, you move to 0, 1 over. So the rabbit will only get 50 milliliters of energy. So we go ahead and pour 50. So the rabbit gets significantly less, right? So there's our poor little rabbit's energy. So he lost a lot of energy to heat. All right, so we got 500 milliliters for the autotrophs, and we have 50 for the rabbit. All right, and all that energy, the in-between, all this was lost to heat. All right, so let's do the next one. So after the bunny rabbit, we have our little snake, right? Mr. Snake. So the snake is gonna lose 10% of what the rabbit had. So the rabbit had 50. So we moved to 0 over 1. So now we're only gonna get 5 milliliters. 5 milliliters. So try and put this down to pour that small. Ready? 5 milliliters. So that snake gets that energy. So again, you can see it's significantly less. So we went from 500 for the autotrophs, 50 for the rabbit, 5 for the snake. And the top of our food chain, the hawk, which was the little box, right, is only gonna get 10% of the 5. So to get 10% of 5, we take the decimal and we move it over once. So he's gonna get 0.5, and I actually have to use a little syringe in order to get that small. So I'm gonna actually dump some in here and pull 0.5. All right, so 0.5. All right, so as you can see, we now have all 5 of our energies. So now we have all 5 of our energies, right? And it was significantly smaller per each animal, right? So which class would you rather have? So autotrophs get 500 milliliters, and it doesn't have to be 500. I just chose that because it was the easiest to measure out. But it can be anywhere from 1,000 to 100 to 25. Whatever the plant converts the energy is what the energy consumption is going to be. So this plant, we're going to say, that had about 500 milliliters of energy that he converted from the sun. So because he doesn't need to convert and lose heat by eating and catching the prey, he gets the most, right? We then get to the rabbit. The rabbit has 10%. 10%. It's called the rule of 10, right? 10% to the rabbit to make 500 goes to 50. So that's a lot less liquid, right? I'd be very disappointed if I got this at a restaurant, right? So this 50 milliliters, all that energy that was lost, all of this, the difference, was lost to heat. So heat was expelled, and that heat was wasted energy that went back into the atmosphere. Well, this is the energy it kept. So for a rabbit to get as much energy as the plant, it's gonna have to eat a lot of plants, right? Because they'll only get 50 per plant. Now we go up to the snake. It's even worse for the snake, right? So we went from the rule 10%, right? We started with 50. We moved the decimal over 1, and it becomes 5. So this 5 milliliters is all the snake will get from eating that rabbit. All the rest is released with heat, right? So all the rest just became heat, was released into the atmosphere. So our plant, who gets 500, which is a perfect drink, our Our rabbit who got 50, which at least it's kind of like, it's a little bit, right? It's enough to get a like little sip. And then the snake, which is just barely enough to count as a taste. But then we have our apex predator. Now being an apex predator, you don't have anybody trying to eat you. But as you can see, the energy you get for the food is basically nothing. So we went from an autotroph to the apex predator. So big difference in energy conversion. So this apex predator is gonna have to eat a lot of animals. Now he doesn't have to worry about animals trying to eat him because he's top of the food chain. But it doesn't make it any easier for him to get energy. So when you think about this, think about the animals that you know. Animals that eat other animals are usually bigger, so they're gonna waste a lot more heat, right? So if they waste a lot more heat, it's gonna take more for them to survive. But what does the biggest animal in the world eat? So the blue whale actually eats something called krill. And krill are the first animal after autotrophs. So that means when he eats one piece of krill, he's only losing 10% of what they got from their food. So he can eat a whole lot of krill a lot faster and lose a lot less energy to the atmosphere. So some of the larger animals actually are herbivores, like the elephant or the giraffe, and they eat things like plants. So if animals eat plants, they typically can get a bit larger in size because of that. Now, is that true for everything? No. In science, nothing's true indefinitely for anything, because there's always gonna be something in the wild that's completely different than how we theorize it to be. But that's okay. That's what science is. Science is an ever-changing thing. Like, we may know how something works, but we won't fully understand it till enough experiments and enough things are known. And some things might never be known. And that is okay. All right, so let's review. So, our 10% rule only applies to the biological pyramid, which is this right here, right? A pyramid. So if it comes in a pyramid, it's gonna have the rule of 10. The rule of 10 means that you lose 10% per going up. All right, so if we start at 1,000 here at the autotrophs, the bunny will only get 100. And 10% of 100, you move the decimal over, it's gonna be 10% for the snake. And if we're at 10 for the snake, we're gonna be at 1 for the hawk. So I want you just to remember that the rule of 10 applies to biological pyramids. It applies to other things too, and the energy that disappears, it disappears as heat, right? So that heat is what is being lost. So please practice doing some energy pyramids, and remember the power of 10, you just move the decimal. I know it sounds more complicated, but it's only moving, just take 1 0 off, all right? So you guys have a good night, and I hope to see you next time.